Hi, this is Sung, and in this episode I want to start off and give an introduction to our very next topic. Alright, so we've done differentiation, we've done integration. What I want to do is revisit some trigonometry, and this time what's going to be different about what we do in trigonometry is that we're going to be adding the components of differentiation and integration to trigonometry. So we're going to be applying calculus to trig, all right, to trigonometry. All right. So the title for this chapter is trigonometric functions, right? And I want to start off by saying we have to actually introduce a new way of measuring angles, all right? And the reason why is that basically with trigonometry, if you were to apply calculus to it, if you were to differentiate it, or if you were to integrate it, you wouldn't be able to do so unless you were differentiating or integrating with respect to our new measure, okay, which is called radians, okay? So basically, you cannot integrate and differentiate in degrees, so we've come up with a new way of measuring angles, and that's called radians, okay? So what is a radian? All right, let's have a look. A radian is defined as the angle made by an arc length the same distance or the same length as one radius of the circle that we're measuring the angle from. Okay, so if we have a circle here, the length of the radius is r, right? 1 radian is defined as the arc length made by r units long. Okay, so if you think about it that way, how many radiuses are there in the circumference of a circle? Obviously, it would be 2 pi r, so you've got 2 pi radiuses or 2 pi radians in the whole circle. The angle for the whole circle would be 360 degrees. Does that make sense? So 2 pi radians is 360 degrees. So what that means is if we divide both sides by 2, pi radians would be 180 degrees. Yes, pi radians would be 180 degrees, and 1 radian would be equal to 180 degrees over pi. Yes, pi being the number 3.14, etc. Okay, so 1 radian is equal to 180 degrees divided by pi, which approximately equals to, I did the calculations earlier, 1 radian is approximately equal to 57 degrees, 17 minutes and 45 seconds. All right, it's approximately equal to that. Okay, now, oftentimes when you're working in radians, you've got to be able to move fluidly from degrees to radians, and vice versa, from radians to degrees. Okay, so you've got to be able to convert between the two units, right? And so I've on the left hand side of the board, all right, or to your right, I've basically got some questions here which involve converting from degrees into radians, and also from radians to degrees. All right, so let me start by saying this. When you're converting degrees into radians, all right, you need to remember your conversion key. Pi radians equals 180 degrees. So to convert 45 degrees into radians, right, what you have to do is divide by 180 times by pi. Got that? So 45 over 180 is pi on 4. Alright? So you're going to have to become really fluid with doing these sort of questions, right? But that is how you do that one. Let's have a look at the next one. 30 degrees, right? Divide by 180 times by pi, right? That's your conversion key. You divide by 180 times by pi. So you should get pi on 6, because 30 divided by 180 is 1/6, right? So that's pi on 6. Next one, 20 degrees. You divide by 180 times by pi, and your answer should be pi on 20 over 180 is 1/9, so 9 pi on 9. 108 degrees, you divide by 180 times by pi. Now this one's probably not going to be as easy for me to work out. Let's see. So that's 12 on 15. 12 on 20, which equals to 12 on 20, 6 on 10, 3 on 5 pi. And then the last one, you divide by 180 times by pi. And sometimes it doesn't come out as a neat fraction, right? So basically, for the last question, what I'm going to do is basically work it out on the calculator. And if you work it out on your calculator, basically what you need to do is you go 324 divide by 180 times by pi. And this, because pi is a transcendental number, your answer is not going to be an equals to, it's only going to be an approximation. So your answer is going to be approximately equal to 5.655 to 3 decimal places. That's what I've got. Does that make sense? Okay. So oftentimes your question will tell you to how many decimal places they want the answer. Okay. If it's an approximation they want. Other times you can just leave it in exact form like I have for the questions above. Okay, good. So now we're told to convert to degrees. So if converting from degrees to radians was about dividing by 180 and timesing by pi, you would expect converting from radians to degrees, you would do the opposite. So you would times by 180 divide by pi. Okay, good. Alright, so you times by 180, divide by pi, you punch that into your calculator, and you should get 60 degrees. Pi on 5 times by 180 divided by pi should give you 36 degrees. 7 pi on 6 times by 180 divided by pi, and your answer for this one should be 210 degrees. I've left 2 examples to the end, which will again involve an answer that is an approximation. Alright? So basically what you've got to do is, the method's exactly the same. You times by 180, divide by pi, and you should get an approximation. So I'll put an approximation sign above. Right. But instead of using a really long decimal, what we need to do, because we're dealing with an angle, is put our angle in degrees, minutes and seconds. So I've got 33 degrees, 0 minutes and 9 seconds. And then the last one, we do exactly the same thing. We times by 180, divide by pi, approximately gives us, and we get an answer of 243 degrees, 57 minutes and 56 seconds. That's how you convert from radians to degrees and from degrees to radians. What I will also say to you is that from now on, when you are finding the trig of an angle, I want you now to think of that angle in terms of radians and no longer think of angles in terms of degrees when applying trig ratios to them. Okay, and a very helpful step in doing that is to understand that your calculator will also have will also be able to calculate in radians rather than degrees. But what you do have to do is change your settings from degrees to radians. Now at the top of your calculator, if you look at the very top of your calculator, there should be a little square box that has a D in it on the top of your screen. So if this is your calculator on your screen, right, you should have a little black box, a really tiny one that you just see at the top of your screen, and that has a D in it. Right? If your screen has a D in it, basically it means that your calculator is working with angles in terms of degrees. Right? What we want to do is change that from D to R. Because if you've got a little R instead of a little D, basically what you're doing is working in radians instead of degrees. So if you don't know how to do that, what I suggest you do is ask your teacher at school how to convert your calculator into radians. Or what you can do is go online on the internet, Google or YouTube how to convert your calculator from degrees to radians and vice versa. Okay, I would highly recommend that because from now on we'll be working in radians. Thank you very much for watching.